Ladies and gentlemen, in this question we are given that cos A plus sine A equals to K, right? That is what we are given. And we are told that K is an acute angle. And on question 8.1, we are asked to determine the value of tan A plus 1 over tan A in terms of K. So we need to write tan A plus 1 over tan A in terms of K. That is the first question. And we are also asked to prove that sine A plus cos A is the same as square root of 1 plus 2k. Okay, so let's do that, ladies and gents. So first thing first, we need to determine the value of tan A plus 1 over tan A. We know that tan A is basically sine A over cos A. And then we're going to have plus 1 over tan is just the reciprocal, right? It's the reciprocal of tan. So we're just going to have cos A over sine A. Right? Because remember, tan A is equals to sine A over cos A. But this is over 1. If I switch and say 1 over tan A is going to be the same as cos A over sine A. All right, so that is the first part of this question. Then let's go on. Now, ladies and gents, we have the LCD. The lowest common denominator we can see from here, that is cos A sine A. Right, the LCD is cos A. Oh, sorry, this is too big. Let's reduce. Sharp. The lowest common denominator is cos A and sine A. So we have to make the denominators the same. So here I can say I need to multiply by sine A, so that I can have cos A and sine A. Here I need to multiply by cos A, so that I can have the same as the first fraction. Whatever I multiply at the bottom with, I must multiply the top with. So here I'm going to multiply by sine A. Here I'm going to multiply by cos A. Okay? Therefore, we're going to have tan A plus 1 over tan A being the same as, here it's sine times sine. So sine times sine is sine squared A, plus cos times cos is cos squared A, all over the LCD, which is sine A cos A, or you can say cos A sine A. The order doesn't matter, right? Because you multiply. And the nice thing is we can see that on top we basically have 1, right? Because applying the Pythagorean identity, we can see that sine squared theta plus cos squared theta equals to 1. So we have 1 over sine A cos A. And that is tan A plus 1 over tan A is the same as 1 over sine A cos A. Right. Now let's use the given information. We are told that cos A plus sine A equals to K, as in the given information. All right. Now let us square both sides. Let's square both sides. Here it means I have two brackets, which is cos A plus sine A, and another bracket of cos A plus sine A equals to K squared. And then cos A times cos A is cos squared A. Cos A times sine A is basically sine A cos A, or you can say cos A sine A. It's up to you. Sine A times cos A is the same as sine A cos A. Sine A times sine A is plus sine squared A is equals to K squared, right? And then, ladies and gentlemen, we can see that cos squared A and then plus sine squared A will give us 1. Okay, those two will give us 1. And then we can see that in the middle we have like terms. Sine A cos A, sine A cos A. So it's 2. So we're going to have plus 2 sine A cos A equals to K squared. Now we need to find sine A cos A. What is the value, right? So I'm going to firstly minus 1. So I'm going to be left with 2 sine A cos A equals to k squared minus 1. And then I divide both sides by 2. Divide by 2, divide by 2. Then I have, therefore, cos A sine A, or you can say sine A cos A, doesn't matter, equals to square root of, right? Let's see. No, actually, we don't have to square root here, sorry. So it's k squared minus 1 over 2. So which means where I see sine A cos A, I can replace by that. Ne? So, and if you check, that is there. It's sine A cos A there. So we can therefore conclude that, therefore, tan A plus 1 over tan A ne, can be written as 1 over, remember we had said sine A cos A, right? So which can be written as 1 divided by, no square root, sorry, k squared minus 1 over 2. Remember guys, this guy is the same as that, which is equals to that. See? And this will be 1 multiplied by 2 over k squared minus 1. Remember, when we change the division to multiply, you must reciprocate the immediate fraction. And then this will give us 1 times 2 is 2 over k squared minus 1. And that is the final answer for 8.1. And then 18.2, what do they want us to do? On 18.2, they want us to prove that sine A plus cos A equals to square root of 1 plus 2k, right? Fine. So let's see how we're going to prove that, ladies and gents, right? Let's see. Okay. Let's see.